is P greater than Q? Two statements are given. We have to find out whether we can answer this question using statement 1 alone or statement 2 alone, or both combined, or both are not able to answer this question. Is P greater than Q? You should have answer either yes or no. It should be absolutely either yes or absolutely no. You cannot say in few cases it is yes, in few cases it is no. We have to draw a conclusion here. Is P greater than Q using these two statements? To draw a conclusion, we cannot have more than one choice here. Two choices possible. That means we cannot draw any conclusion. Every time you should get yes or every time you should get no. In some cases you are getting yes, in some cases you are getting no. You cannot draw any conclusion. So in that case you cannot answer this question using these two statements. This is the crux of data sufficiency questions. In data sufficiency questions, try to disprove the statement using simple values, trial and error method. We'll see how to do that. If trial and error method doesn't work, then try to generalize the problem. We'll also see that. Trial and error method is very easy in nature. You can easily find out which problem can be solved using trial and error, which problem you need to generalize. By looking at the problem, you can easily tell that. Statement 1 says P into Q is greater than 0. I am taking P as 2, Q as 1. 2 into 1 greater than 0 satisfies. Here, in this case, P is greater than Q. If I have P as 1, Q as 2, P into Q, 1 into 2 greater than 0. But in this case, P is less than Q. Here is P greater than Q, answer yes. Here is P greater than Q, answer no. When you have two choices, you cannot draw conclusion. That means you cannot answer this question using this statement. Now statement 2, P square greater than Q square. Say you have P as 3, Q as 1. 3 square, that is 9 greater than 1, satisfies. In this case, P is greater than Q. Yes. If you have P as minus 3, Q as 1, P square 9, Q square 1. So P square is greater than Q square, but P is less than Q here. Minus 3 is less than 1. So is P greater than Q? No. So you cannot answer this question using this statement also. So the question can be answered by using one of the statements alone, but cannot be answered using other statement alone. No, wrong. It cannot be answered using statement 1 alone and statement 2 alone as well. So this is also wrong. Can it be answered by using both statements together? So statement 1 says P into Q greater than 0. Statement 2, P square greater than Q square. See, I am trying to combine these two statements. P square minus Q square greater than 0. From this statement, P into Q is greater than 0. So 2 into P into Q is also greater than 0. Here, 2 into 0 is 0, so I just wrote 0 here. I am multiplying with 2 on both sides. Now P square minus Q square, I am adding 2PQ to this equation on both sides. You see, I can't find a relationship between P and Q here. If this would have been plus, then I would have got P plus Q whole square greater than 2PQ. So this is greater than 0. Square is always greater than 0. And in any case, since this is greater than 0, okay, this would be greater than 0. This way you can find out a relationship between P and Q or P and minus Q. But you have minus here. So when you do like this, you cannot write in the form of A plus B whole square. And the UPSC is not going to complicate this much. Simple basic inequalities they will give you. Based on that only you have to answer. When you have this kind of inequality, what is the value of P and Q? What is the range of P and Q? Though we taught this in algebra, you don't need to go to that level. If this question can be answered using both the statements, you will see a clear relationship between these two statements. When you don't find a clear relation between these two statements, that means you cannot answer this question using both the statements together. So our answer is D. Is P plus Q minus R greater than P minus Q plus R, where P, Q and R are integers? If you see here, we have three variables P, Q and R. P plus Q minus R greater than P minus Q plus R. Is this? This is the question. You can cancel out P on both sides. You can bring Q this side, Q plus Q, 2Q greater than. You can bring R this side, 2R. So Q greater than R. Is Q greater than R? This is the question. We need to have answer either yes or no. We cannot have both. Now statement 1, P greater than Q. P minus Q is positive, means P minus Q greater than 0. You bring Q this side, that implies P greater than Q. So we need a relationship between Q and R. Here we have a relationship between P and Q. So we cannot answer this question using this statement alone. Let's make use of statement 2. P minus R is negative, less than 0. That implies P is less than R. Now combine both. See, you have a relationship between Q and R. Here you have a relationship between P and R. So you cannot answer this question using this statement alone. That's why we are combining both these. P greater than Q and P is less than R. So from this we can say R is greater than Q. That means Q is less than R. The question is Q greater than R? No. Generalized it. No matter what are the values of P, Q and R, we can always say Q is less than R. So this can be answered by using both the statements together, but cannot be answered using either statements alone. So answer is C. You have three variables. It's not that easy to answer this question using trial and error method, using simple values. You have to try number of values and try to disprove them. However, if you make use of generalization method, you can answer this very easily. We generalized this no matter what are the values of P, Q and R. In a party, 75% took tea, 60% took coffee and 15% took both tea and coffee. No one taking milk takes tea. Each person takes at least one drink. How many persons attended the party? We have to answer this question using this information and these statements. I am making use of Venn diagrams to solve this problem. Using Venn diagrams, we can solve this problem easily rather than formulas. You should know when to use Venn diagrams and when to use the formulas. This comes with practice. 75% took tea. Number of people taking tea. This black circle is 75. 60% took coffee. This pink circle is coffee. 15% took both tea and coffee. This is 15. This total is 75. So this will be 60. 60 plus 15, 75. This area is 60. Those who are drinking tea only. Tea and coffee 15. This is milk circle. No one taking milk takes tea. Milk and tea, they don't have any overlap. They don't have anything in common. Each person takes at least one drink. So all the persons somehow will fall in these circles. They won't be outside. Say this value is Y. We don't know it. Just assume. And this value is X. What is this value? This total is 60. So 60 minus this 15 minus X, right? That is 45 minus X. This value is 45 minus X. How many persons attended the party? That would be the 60 plus this 15 plus 45 minus X plus this X plus Y. So total number of persons, this is the value. Now minus X plus X cancels out. 75 plus 45, 120, 120 plus Y. Now to know this value, we need Y value. This value does not depend on X. Kindly see this. Now statement 1 says 50% took milk. This is 50. X plus Y is 50. We cannot find out Y value using this equation. To find out Y value, we need X value. X value we don't know. So we cannot answer this question using this statement alone. Let's have a look at statement 2. number of persons who attended the party is 5 times the number of persons who took milk only. Milk only is this. Number of persons who attended the party, that is T, is equal to 5 times who took milk only, Y. You can substitute T value here. 5y is equal to 120 plus y, 4y is equal to 120, y is 120 by 4, that is 30. Once y value is known, you can find out this value, T value, 120 plus 30, 150. Now, how many persons attended the party? 150. So, the question can be answered by using one of the statements alone, that is statement 2, but cannot be answered using the other statement alone. Yes, this is our answer. By using either statement alone. No, wrong. You cannot answer this question using this statement. Together we don't need. Cannot be answered even by using the statements together. No, wrong. This can be answered just using this statement. Consider a 3-digit number. What is the number? This is the question. Now, statement 1. The sum of the digits of the number is equal to the product of the digits. The number is divisible by the sum of the digits of the number. The digits which satisfy this condition are 1, 2, 3. Say you have number 1, 2, 3. Sum of the digits 1 plus 2 plus 3, 6. Product of the digits 1 into 2 into 3, 6. Now 3, 2, 1 also satisfies this condition. 3, 1, 2 also satisfies this condition. Number of possibilities. This space can be filled in 3 ways. This space in 2 ways. This space in 2 ways. 6 such possibilities. 1, 2, 3. 1, 3, 2, 2, 3, 1, 2, 1, 3, 3, 2, 1, 3, 1, 2. So which 3-digit number? We cannot say using this statement. The number is divisible by the sum of the digits of the number. Sum of the digits 6. If it is divisible by 6, that number should be even number because 6 is even number. Even number into something, you should get even number, right? So this number should be even. These are two even numbers. If you see 132, it's divisible by 6. 312 also divisible by 6. This is divisible by 2. This is divisible by 3 as well. This is divisible by 2. This is divisible by 3 as well. You can check 6 divisibility like this. Here also using statement 2, we are getting 2 choices. So we cannot tell which 3-digit number is that. So the question cannot be answered even by using both the statements together. Answer D. For 5 children with ages A less than B less than C less than D less than E, any 2 successive ages differ by 2 years. First children age you take as A, B would be A plus 2, C would be A plus 4, D would be A plus 6, E would be A plus 8. They differ by 2 years, any 2 successive ages. So this is what that means. What is the age of the youngest child? We have to find out A value. The age of the eldest is 3 times the youngest. A plus 8 is 3A. So 2A is 8, A is 4. We can answer this question using this statement. Now statement 2. Average age of children is 8 years. Average is 5A plus 8 plus 2, 10. 6 plus 4, 10. 20 by 5, that is 8. One equation, one variable. You can find out the value of A using this equation. So this question can be answered using this statement also. So the question can be answered by using either statement alone, either this statement or this statement. So answer B.